All right. So, we did a little note like this last time we did our mirror labs. Now we've just completed our lenses labs. So this note, and we can put a date on it, what is it, November 16th?
Yeah.
November 16th, 16, that's kind of exciting, 1616. And this is called Rules for Ray Diagrams for Lenses. All right, Rules for Ray Diagrams for Lenses. And we're going to start A with converging lens. And I'm going to start by just drawing a line which represents the principal axis. That represents the PA. Now remember, the converging ones are the ones that are fat in the middle. I don't have the little prisms anymore, but there we've got one that's fat in the middle. And in the middle of that line, draw another line that's perpendicular to it. You can get it to be 90 degrees by using one of the centimeter marks. And draw a line that's perpendicular, and it can be 1.5 centimeters or so. It doesn't matter how tall it is. And that's going to be our lens. And we put the arrows on it like this because that's supposed to represent the fact that it's fat. That is a converging lens picture. That's how we do it. Because this arrow is supposed to represent that it goes around here on a curve. Now we're going to take our ruler and let's use 2 centimeters as being our focal length. So I'm putting the 2 on my lens, and I'm going to mark on here a PF at 0. See there? A PF at 0. And at number 4, I'm going to write on an SF. All right? And we're going to do the rules. Rule number 1, a ray that comes in parallel to the PF. Remember, these are all converging. These are our fat lenses. Well, you tell me. A ray that's parallel to the PF will go through. Sorry, not the PF, the PA. A ray that's parallel to the PA will go through SF. There it goes. That's rule number 1. We'll write that down in a minute. A ray that goes through, you know what? I've got SF and PF backwards, don't I? PF is on the far side. I apologize. Hopefully everybody's got pencil there. If not, you'll have to do a little scribble move. PF is on the far side. SF's on the front side. So a ray that's parallel goes through PF. A ray that goes through SF on an angle, how's it going to come out? Yep. Parallel to the PA. Parallel to the PA. There's rule number 2.
I just realized if you extend the lines long enough,
They'll meet and they'll make an image. But that's you could imagine that these rays actually came from an arrow, but I haven't put an arrow on it yet. We will start with we'll do the arrows in a moment. Rule number 3, and I'm going to just put it down here to get it out of the way. A ray that goes through the center of the lens, what does it do? A ray that goes through the center goes straight on through. Rule number 1, a ray parallel to PA. That sounds like a rhyme. A ray parallel to PA. No, we're not rhyming. Pat, that's not your thing. will go through PF. A ray parallel to PA will go through PF. A ray that goes through SF will emerge. Emerge means comes out, right? How will it emerge? Parallel to PA. To PA. Parallel to PA. 3. A ray that goes through the center, comma, goes how? Straight through. Now, many of us just finished the diverging lab, but I don't want to talk about diverging rules yet because I want to now go through drawing some ray diagrams with some real images. So again, because this is a real pain to have you draw out every time, I'm giving you a piece of paper for this one. All right, there's 2 there, Max. There's 2 there. 4, like that. Okay. So again, just like we did for mirrors, we're imagining what happens if I take a lens like the, if I take a lens like this that's converging, and I have an object like maybe this container with pencils far away beyond the 2F. You can see there in that first picture, beyond the 2F. I want to find where the image is. How many rays do we need to locate the image? Yep, we only need 2. We've got 3 rules, but we only need 2. So now at this point, and I'm hoping I'm going to take this away, and I'm going to give that right to Jacqueline, so she can copy it right down from the piece of paper. Max, did you get a piece of paper yet? Did you get one? Okay. And we will work together on finding these. And notice we're looking for salt again. We want to look for the properties. So if you think you know how to do this, you can go ahead. Like from the top of the arrow, which is my object, I'm going to have a ray that goes in parallel to the PA. And you don't have to wait for me. Where does it go? Yep.
Through SF.
Not SF.
PF.
PF. Yeah, because I screwed that up, remember? Through PF. There's PF there. Now, my favorite ray for drawing any of these for lenses is the third one. Through the center. Because it's the easiest. You don't have to move your ruler. You don't have to do anything. So I always use the third one as my second one. So let's do that. A ray that goes through the center. A ray that goes through the center goes straight on through. We are doing this paper right here, and you'll need a ruler. So you'll notice, here's where it meets. There's the top of my arrow. There's the bottom of the arrow. The arrow always touches the PA. The base of the arrow does. And this is my image. I could have used the other ray. A ray that goes through SF comes out parallel. It would have found me the same spot, but I don't want to add too many rays to this picture. Salt. How is my image compared to my object? How is my image? Yep. Smaller. So it's small right here, Logan, you'll need a ruler. Small and attitude. How is this image? It's inverted. Location. Describe the points that's in between. Between PF and 2F. Now, the type. This is different than for mirrors. All right? For a mirror, we expect the light to reflect back. And the real world for a mirror is in front of a mirror. For a lens, because it's transparent, we expect the light to go through. Light should go through a lens. It's transparent. So for a lens, it's opposite. The real world is on the opposite side of the object because we expect the light to go through. And the virtual world is on the front side of a lens because we don't expect light to go backwards through a lens. That doesn't make sense. So that's the virtual world. So because our image is over here on the opposite side, this is real. We would be able to project that onto a screen, and I'll show you that tomorrow when we talk about uses for lenses. Let's do the next one. We've moved up to 2F. Again, I like a ray parallel to the principal axis goes through PF. Don't wait for me. You can do that yourself. And again, I like a ray that goes through the center, goes straight on through. Those two are the easiest to do. And I only need 2 of them. Mine didn't work so great. At 2F, where do you think my image should have been? At 2F. It's like in our mirrors when we had C. If it was at C, it was back at C. Mine didn't work so great. When the object is at 2F, its size, what do you think it should be? This is not bad, it's pretty close. Yep, same. Attitude, inverted. Yours might be a little behind. If you made a little error on that one ray, it moves it. Don't worry about it. Location, I'm going to put here at 2F because that's where it's supposed to be. What type is this?
Real.
It's real. It's on the opposite side. So it's a real image. We could put that on a screen. And again, I'll show you that tomorrow. All right. We're continuing to move our object in. Let's now do this one here where the object is in between 2F and SF. I can still use my 2 rays. My 2 rays are awesome. I can go parallel through PF and through the center. So I might as well keep using those. The other one is if it goes through SF. I don't really like that ray. It's kind of a tricky ray to do. A ray that comes in parallel goes through the PF. A ray that goes through the center. And notice I didn't make my one ray long enough. I still haven't got the intersection point. So I have to extend my ray a little bit. I got to make it a little longer. And you can see here, there's the head of the arrow. It's way back there. There's my image. I'm gonna ask some questions for Salt here, and Cade's gonna try to prevent his impulse answering. Size, Max?
Bigger.
Bigger. Attitude, yep, Jake? Inverted. Location, just describe it compared to the closest thing. It's beyond 2F. Beyond compared to the lens. Beyond 2F. And what type is this? Lucas, what type is it?
Real.
It's real. It's on the opposite side. It's real. That could go on a screen. It'd be really big and upside down.
What's it called when it's on the other side?
Virtual. Virtual. It's not real. It's virtual. Okay. Let's now move to SF itself. We've got the object right on the focal point. Use the same two rules that we've been using all the way along. You don't have to wait for me. Array that comes in parallel goes through the PF. Array that goes through the center. Where are those two rays going to meet? What do you think? They don't meet. If they don't ever meet, they never cross. Can there be an image? No, there's no image. No image. When it's at the F, there is no image. Is that a question?
Yeah. How would you do a ray through SF?
You couldn't this time. It would actually go straight up and down. It would never hit the mirror.
So is that how you would know
Not necessarily. I guess so. I guess in this case it is true that if you had that SF rule, it would never hit. But you got to be careful with that. It's the fact that these two never meet. That's why you don't have an image. Now the last one. And my paper's running into things here. So again, we can use the same two rules. A rule that comes in, goes through PF. A ray that goes through the center, goes straight on through. Now notice these two. They're not going to meet out here because they're spreading out. But what do we do whenever we have rays that spread out? What do we do? Put them in behind. So we're going to put our rulers back on the ray, and I'm going to extend them in behind with a dashed ray, because it's not a real light ray. It's a virtual light ray. I'm going to do the same with the other one. You can see right there is where those meet. That's where our eyes are going to think that the image is. Size. Yep, Jake? Bigger. Attitude. Jake? Upright. Location. You can again compare it to things that are on the PA. Between 2F and SF. And what type is this? Yep,
Virtual.
It's virtual. You won't be able to see this on a screen, and you'll have to look inside the lens to see it. And that's like a magnifying glass. When you get something really close, it's going to magnify it. Okay. And that's what we do for converging. Now, I'm going to finish off with a little description of what we do for diverging. So back to our note. Again, you can put that in your notes. So you'll notice it's got holes in the bottom there. You can fold that up like that so that you can save it. And then you can have the holes hanging out the bottom. And then you can put that off to the side. Okay. So the top of our note said rules for converging, and I've lost that. Oh, I gave the piece of paper up there. That's awesome. I will use that one again. Thank you. So you'll notice it says rules for converging. Now down here I'm going to put B diverging lens. And I'm going to draw a principal axis.
I always spell lens with an E.
Lenses. I don't even know if I'm spelling that right. It could be my mistake. Maybe it's just lenses. I don't think the plural's got to be lenses, but anyway.
I don't know.
Let's put on a lens in the middle. Again, we want it to be perpendicular. Do the best you can. I don't care how tall you make it. To indicate that it's diverging, we put our arrows pointing the opposite way to represent the fact that it's skinny in the middle and fat on the edges. Again, I'm going to use, what did I use last time? 2 centimeters?
Yeah.
2 centimeters. We'll do the same. 2 centimeters. But this time the PF is on the front end and the SF is on the back end. And that's what I did wrong on the one at the top, but I fixed it. A ray that is parallel to the PA. Remember, it's diverging. So it's going to bend up and away. But it's going to bend up and away as if it came from PF. I'm going to draw a dotted line on the one side because we are going to have to extend it in behind. And I did a really crappy job there. See how that's not really lining up there? That was bad. Number 2, and you know what? I don't use the rule number 2. I will draw it on. A ray that appears to go through SF. So if we've got a ray coming in here like this, and it looks like it's going to go through SF, what does it do? It comes out parallel. Now, if you ever use that ray, again, we extend it in behind, but I don't like that ray. That's a tricky ray to draw. So I'm not a fan of number 2. Number 3 I do like, it's great. It's the same as the other one. A ray that goes through the center, what does it do? Keeps on going. That is the worst ray going through the center. Do you see that? That is not even close to the center. I apologize for my sloppy rays. That second one is a ray that appears to go through SF. Is that what you're looking at, Jacqueline? That number 2 ray? Yeah. So I line up my ruler up with SF. But then I don't have it go straight through. I have it stop and come out parallel. All right? I'm going to write down rays 1 and 3. A ray parallel to PA. Again, it sounds like a rhyme. This is even better. Will bend away. A ray parallel to PA will bend away. No? You're not enjoying this? I'm having some fun here. Will bend away as if to come from PF. And that doesn't rhyme. 3. A ray through the center goes straight through. A ray through the center goes, oops, look at, I did my spelling mistake of goes. Goes is one of my pet peeve words. I always spell it wrong. I get the E and the S backwards. Goes, I fixed it. Straight through. UGH. Now, I do not have a piece of paper for the example. And that's because they're all the same. So I'm gonna draw one, and I'm gonna have you draw it. I'm gonna actually draw it on the bottom of my page. So hopefully you got a little more room to draw one more diagram. Again, a principal axis. Again, a lens. Oh, look at that's terrible at parallel, isn't it? Maybe it's the camera angle. I don't know.
No, it's correct.
It's crooked. It's crooked. It's terrible.
No, let's just say it's the camera.
Anyway, yeah, I can blame it on the camera lens. Again, let's measure 2 and 2. PF, SF. And let's put our object just beyond the PF. It really doesn't matter because all of the properties are the same. Rule number 1, from the top of the arrow, a ray that comes parallel to the PA will bend away as if it came from the PF. So I put my ruler on the PF, I put my ruler on the point where it touched. I'm going to draw a dashed line on the front side and a solid line on the back side. Because the dashed line isn't a real ray, it's a virtual ray. Rule number 3, a ray that goes straight through the middle goes straight through, and right there is where they meet. There's the little arrowhead. There's the little arrow. There's the image. Size, Max?
Smaller.
Smaller. Attitude. Jake? Upright. Location between PF and the lens. And the type. What type is it? Nolan? What type? Virtual. It's on the front side. We don't expect images to be on the front side of a lens. Virtual. Okay. That's how we draw ray diagrams for lenses. Again,